Hello friend, welcome to our new videos of CodingPy. In this video I am going to tell you that how you can build object detection and counting project. For this I will show you that how you can use deep learning model for object detection. This project is especially for beginners who wants to upskill their knowledge and used in college as their mini project. So without wasting time, let's get started. First thing first, what you need to do, open your Jupyter notebook or Google Colab and then install all the necessary libraries. Here I already installed it, so it says requirement already satisfied. Now in next step what we need to do, we just import all the necessary libraries. Gradio for creating user interface, CV2 for image processing where we can convert image into a format and it is used to draw a bonding object in an image. Now Ultralytics provide a YOLO V8 which is pre-trained deep learning model used for object detection and counting. At last I used to import NumPy for numerical computation. NumPy basically handle image as array. Now in next step we will import pre-trained model YOLO V8. It is faster and suitable for mini project. Here I successfully downloaded the model which is up to 7 MBs file. Now in next step define a function which names as detect and count object which consists two parameters, image and object name, where object name is already defined, that is person. Next we need to convert the image into RGB format. For this I used to define a variable named as image_RGB. Then CV2 provide a function called CVT color. With the usage of this I can convert the images into RGB. RGB stands for red, green, blue, which is primary color of light. It is used to represent and display images to electronic system. Then in result variable you can pass converted image to the model. Now define a variable called detection and extract bonding boxes from the result. Now next you will define detected_object variable which consists empty list. Now with the usage of for loop, extract boxes from detection variable, then append it to detected_object. Next you annotate the images with their bonding boxes. Again with the usage of for loop, extract bonding box coordinate and convert coordinate into integers using map function. Then extract confidence score, which means probability that object is correctly detected. Then with the usage of CV2, draw bonding boxes in rectangle format. Again use CV2 to put object label with their confidence score on top of the rectangular image. Now defined a count variable to count the detected object. Finally return three variables, that is image, object count and object name. Now in fourth step you can process image for Gradio. This you can define a function named as process_image. Consists two parameters, that is image and object name. Now you can convert input images into NumPy array and store it into a image variable. Then you need to call a function that is detect and count object which requires two parameters, that is images and object name. Then whatever value that you got from function you can store it in these two variables, that is annotate_image and count_message. Then you need to return that two variable. In order to make user interface stylish and attractive, you can use CSS along with Gradio. Now finally I used to run the code and as you can see the public URL appear below. Soon as you click on public URL you will redirect to the UI. Wait for few seconds for user interface. Now upload the images, whatever image that you want to upload. As soon as you will upload the images, you can now click on the submit option and within few seconds you will get predicted result. So this is how you can build object detection and counting deep learning project. And trust me guys, this type of content you will never get anywhere on YouTube. I hope this video is informative. Please do like and subscribe and share with your friends. Hello guys, welcome back to the new videos of CodingPy. Today I am going to show you that how you can build age and gender prediction web application. This is project 2 out of 50 plus project. So without wasting time, let's get started. So at first install all the required libraries which includes Gradio, Torch Vision, Team, OpenCV Python, NumPy and Pillow. And here you see that some of the libraries I already installed, so it says requirement already satisfied, and some of the libraries are getting installed, and here you can see that it requires 1 GB of data. Now for time being I am going to skip installation part. Now import all the required libraries for this project. Now here I can use Gradio for creating user interface, CV2 provided by OpenCV Python for face detection, Torch and Torch Vision is used for loading the model, and at last NumPy and Pillow is used for image processing. You can see that I have successfully imported all the important libraries for this project. Now in next step we have to load the pre-trained model, that is fair face. This model is used for age and gender prediction. For this here I created encapsulated class name as age and gender predictor, which consists functionality for predicting age and gender from image. Here I use encapsulated class because I want to bind the code and data together. So for this, define a constructor with self parameter. It is used to initialize the object when instant is created. Now load the pre-trained model with 18 number of classes and store it to self.model. Now with the help of eval function, I used to evaluate the model. In PyTorch it is very necessary because some layers of model behave differently. Afterward, process the image using transformer. Here you can resize the image into 224 by 224 pixels, which is expected input for the model. In your case it might be different. Next you transform the images into tensor and then normalize it with mean and standard deviation. And these values are typically used for model which is pre-trained on ImageNet. Now here you finally define a function called predict with two parameters, that is self and image, to process the image for predicting age and gender. With the usage of unsqueeze with 0, I used to add a batch dimension to the tensor because model expect input in batches even if the batch size is 1. Next I used to load the model and predict the output. And one thing is very interesting here. PyTorch provided no grade function which ensured that gradient are not computed during inferences. So it is not only save the memory but also boost up the process. Next I used to convert output into probabilities with the usage of activation function called softmax. Here I use this activation function because of multi-class classification. Then whatever value that you got, store it to probabilities variable. Next I used to predict the age and gender. For this, out of 18 classes, the first two classes correspond to the gender, that is male and female, and remaining 16 classes correspond to the age group. So with the usage of argmax function, I used to find index with highest probability which represent the predicted gender as well as age group. Now with the usage of conditional statement, I used to separate male and female and store the value into the gender variable. Next I assume that age group is multiple of 5. I multiplied age index with 5 and store it to the age variable. Now finally I used to return these two variables, which is age and gender. Next I used to initialize the predictor by calling age gender predictor class and then save it to the predictor variable. And here you can see that I successfully initialized the model, which is up to 18 MBs of file. Now next step is face detection and prediction, and this is very important step. Whatever input that you got from the Gradio, you need to convert into a proper format. For that I used to define a function called predict underscore age underscore gender, and I used to pass image variable to it. So inside the try and accept block, I used to convert image into numpy array and then save it to the image underscore cv variable. And I used to convert the normal image into BRG format using CVT color function. Now predict the face using OpenCV through Cascade Classifier, which provide har cascade frontal face XML file, which is used to detect the face of the image. Then whatever value that you got, you can save face underscore cascade variable. Next I used to convert the images into grayscale because har cascade works better on grayscale image. Now with the usage of CVT color function, you can convert the images into grayscale and then save it to the gray variable. And this you need to pass to the multi-scale detector and then save it to the face variable. Some users are just like a maniac who used to upload images with no face. So in order to handle that one, you can use logic with conditional statement. Next you need to extract first detected face. For this I used to pass 0 to the face variable, and face region is extracted from the images using coordinate of the rectangle, and save it to the x, y, w and h variable, and pass this variable to the image underscore cv variable and save it to the face variable. Now extracted face is converted back to the PIL format using image.fromArray function. Now for finally predicting age and gender, I used to call predictor object of the class which provide predict function, and I used to pass PIL underscore image to it. And whatever value that you got is stored inside age and gender variable. Now finally return the age as predicted age and gender as predicted gender. and if any exceptional error will occur during the process, it is caught under the try and except block of code. Now, in order to make your user interface stylish and attractive, you can use CSS along with Gradio. Then first what you need to do, define a variable called interface and then called Gradio interface class. Inside that I used to define a variable called fn. I called a class called predict_age_gender. Then I pass uploaded image as input to it. After processing, it will give predicted output inside the text box. Then I used to define a title, description and import the custom CSS, and also I used to mention that theme should be compact. And with the usage of launch function, I used to launch the interface. After running all this code, you will get a public URL, and when you click it, you will redirect to the public UI. Now here you can upload the images, whatever image that you want to upload. Scroll it down and click on the submit option, and after few seconds you will get predicted age and predicted gender inside the text box. So this is how you can build age and gender prediction web application. I hope this video is informative. Please do like, subscribe and share with your friend. Thank you. That's all for this video. Hello guys, welcome back to the new videos of Coding Pie. In this video I am going to explain you that how you can build machine learning web application using artificial neural network. So without wasting time, let's get started. First thing first, what you need to do, just open your IDE, that is Integrated Development Environment, and quickly install all the requirements. Here I used to install Gradio, NumPy, Scikit-learn, TensorFlow and Pandas. In my case it is already installed, so it says requirement already satisfied. Now in next step, import all the necessary libraries. Here I import Gradio for creating user interface, NumPy for mathematical computation, Pandas for data ingestion as well as manipulation. From sklearn.dataset I used to import iris dataset. From sklearn.model_selection I used to import train test split. This is used to split our dataset. Then after I used to import sequential approach from tensorflow.keras.models. Sequential layer is a linear stack of layer where you can add one layer at a time. Each layer has exactly one input tensor and one output tensor. After from tensorflow.keras.layer I used to import dense layer, which is fully connected layer. It means every neurons in this layer is connected to the every neurons in the previous layer. And finally from tensorflow.keras.utils I used to import to_categorical. This function is specifically used for classification tasks where you can convert class level as integer. Now in third step I used to load the dataset. This I used to call the load_iris function and store it to the iris variable. Next I have to separate the feature variable and target variable. Feature variable are those variables which are required as input at the time of prediction, and target variable are those which is to be predicted based on feature variable. So iris.data provide all the feature which is to be stored in x variable, and iris.target provide all the targeted features which is to be stored in y variable, and iris.target_name provide all the targeted features which is to be stored in target_name, that is to be predicted. Now in next step I used to display the top 5 rows of the dataset. For this I used to convert data into a data frame. Here Pandas provide a function called data frame. Beside that I used to pass x as feature data. Then iris.feature_name provide all the feature columns which is to be stored in column variable. Then together all these things store it to the df variable. Next y contain specifically 0, 1 and 2 which represent the species of the flower. So I add a species as column to the y. Next, with the usage of map function, I used to map all the species to their respective numbers. Now finally I used to print top 5 rows of the data frame using head function. Here you can see the top 5 rows of the data frame which consists sepal length, sepal width, petal length, petal width. And in bottom you see the type of flower species. Now quickly move on to the next step. Here I used to convert the data type of the target variable with the usage of to_categorical function which requires data and number of classes. Next I used to split the dataset into train dataset and test dataset. And this step is quite important in order to protect data from leakage. Inside the train_test_split function I used to pass 4 variables which include x which is called feature as well as independent variable, y which is called target as well as dependent variable. Here I also mentioned that test size should be 20%. In order to get rid of shuffling, you can pass any number to the random_state. Next, I used to build the artificial neural network model with the usage of sequential approach. Here you can see very basic and quite simple neural network. First dense layer is called input layer, second dense layer is called hidden layer, and third dense layer is called output layer. Here I used to pass input underscore shape, which is 4, which is correspond to the 4 features, that is sepal length, sepal width, petal length, petal width. And here I used to pass 10 neuron for every input features. Then finally I used to define the type of activation function. In my case it is ReLU. And if we talk about activation function, what really it is basically control the neurons when to fire, when not to fire. This depend on type of activation function that you may use in your layer. So when the signal is strong and positive, ReLU fire the neuron which contribute to the decision making process. Now for the next dense layer, here I use 8 neurons with ReLU as activation function for 10 input features. Now at last for output layers, I use softmax as activation function with 3 neurons. Here one thing you notice that from last 2 neurons I don't define the input shape, because every output neurons from the previous layers becomes input to the next layer. So that is why I don't need to define input underscore shape for the next 2 layers. After running the code, now quickly move on to the next step, that is compile and train the model. Here you can see model.compile, which is a method in Keras which is used to configure the model for training. Here I use Adam as optimizer, which is an algorithm that updates the model weight during training. Then I used to define categorical underscore cross entropy as loss function, which is used for multi-class classification problem where the target labels are one hot encoded. Typically loss function is used to calculate the difference between the predicted distribution and the true distribution. And after I used to define matrix, which is used to evaluate the performance of the model during training and testing. Accuracy is commonly used for classification task, which is used to measure the percentage of the correctly predicted label over the total number of samples. Then model.fit method is used to train the model, take training data and adjust the model weight to minimize the loss function. And here I set the epoch value up to 100 with batch size 5 and verbose equal to 0 because I don't want to show the result. Now finally I used to define a predict function, because whatever input that I got from the user interface, I need to convert it into an array and then I need to pass to the model to predict the result. So here I define a function called predict underscore iris with 4 parameters, which include sepal length, sepal width, petal length, petal width. These parameters need to be converted into an array using numpy and then store it to feature variable. Next I used to pass feature to the model.predict and store it to the prediction variable. Then in order to predict the result, I used to pass prediction to the np.argmax function, then store it to the predicted underscore class. Finally I return the predicted underscore class as predicted flower. Now finally I use Gradio for creating user interface. First I used to define a variable called iFace and then I need to call interface class using Gradio. Then inside that class I used to define a variable called fn where I called predicted underscore iris function. I also define input variable with 4 parameters. Then I need to take output as text format. Next I used to define title, description and theme. Now after running the code, scroll it down and here you can launch the app using iFace.launch function. As soon as you run the code, you will get the public URL, then click on it. Wait for few seconds and you will be redirected to the public user interface. Now here you can clearly see that user interface require 4 parameters, that is sepal length, sepal width, petal width, and it also has 2 buttons, which is clear and submit, and then when you click on submit you will get the result. Now quickly I fill the requirements and I used to click on submit options. As soon I click on submit, I will get the predicted result. So this is how you can build machine learning web application using artificial neural network. I hope this video is informative. Please do like, share and subscribe for more informative videos. Hello guys, welcome back to the new videos of CodingPy. This is project 4 out of 50 plus AI project. In this video, I am going to explain you that how you can build AI powered sentiment analysis web application with the usage of Gradio and Hugging Face transformer in Python. So without wasting time, let's get started. So at first open your Google Colab Then install all the necessary libraries, which include Gradio and Transformer. In my case it is already installed, so it says requirement already satisfied. Now here you can see that I have successfully installed all the requirement file. Now next what you need to do, just import Gradio as GR for creating user interface, and from Transformer import pipeline for loading the pre-trained model for sentiment analysis. Now in next step we have to load the sentiment analysis model. For that I used to define a variable called Classifier. Then with the usage of pipeline I used to import sentiment analysis pre-trained model from Hugging Face, and this is up to 200 MBs of file. Quickly move on to the fourth step. In this step I used to define a classification function named as classify_sentiment, which requires one parameter, that is text. Next I used to pass text to the classifier with index 0, then save it to the result variable, and from result I used to extract label and then store it to the label variable. Next, with the usage of conditional statement, used to state that if label is positive then sentiment must be positive, if label is negative then sentiment must be negative, otherwise it is neutral. Now finally I used to return the sentiment. Now I used to quickly run the code and move on to the next step. This is last step because in this step I used to create interface using Gradio. Finally here you can see I used to define a variable called interface, and with the usage of Gradio I called the interface class, and inside that I used to pass classify_sentiment function and store it to the fn variable. Then I used to define a variable called input. Then I used to create a text box with the usage of gr.textbox with 3 lines. Then I also defined a variable called placeholder and labels, and then I also said that interactive must be true. Next I used to define output, and similarly with the usage of gr.textbox I used to create a text box, but this time it is not an interactive. Finally I used to define labels, title, description and so on. And with the usage of interface.launch function I used to launch the interface by running the code together. Finally I got the public URL. After clicking on it I will redirect to my user interface. And finally here you can see the interface, which consists 2 boxes. The first box is input box, second one is sentiment result box. And finally here you can see whatever I write inside the text boxes as input, then it will reflect as positive or negative based on my sentence. So that's all for this video. I hope this video is informative. Please do not forget to like, share and subscribe. Hello friend, welcome back to the new videos of CodingPie. Today I am gonna show you that how you can build AI powered text summarizer. In this video you will learn about what are the pre-trained models that are available for text summarizer, and with the usage of simple pre-processing step. On top of dataset you will get good result. So without wasting time, let's get started. So quickly install all the necessary libraries, which include Gradio and Transformer. In my case it is already installed, so it says requirement already satisfied. Next I used to import the necessary module, which include Gradio for creating user interface. I also used to import regular expression, which is useful in text pre-processing. Next, from Transformer I used to import pipeline, which helps to load the AI model for summarization. Our next step is load the summarization model. For this I used to define a variable called summarizer, and here you can see the pipeline consists 2 parameters. Summarization is a task which is to be performed on top of dataset with the usage of model BART-large-CNN. BART stands for Bidirectional Autoregressive Transformer, that is to be provided by Facebook. Pipeline function is high-level API provided by Hugging Face Transformer. It simplifies the process of using pre-trained model for various natural language processing tasks. Now after running the code, your device is going to be set to use the CPU. Now quickly move on to the fourth step, where I defined pre-processing function. This function is pretty much important because it reduces the summarization time. So for that we have to clean the data before feeding into the NLP model. Now here as you can see, process underscore text is a function which consists one parameter, that is text. With the usage of text.strip function, I used to remove leading and trailing white space from the text, then store it to the text variable. Next, with the usage of re.sub function, I used to replace multiple consecutive white space character with single space, then again store it to the text variable. Next, I have to remove the unnecessary character from the text. At the same time, I also need to keep the important one. For this, again I use sub function which is provided by regular expression. So here you can see whatever inside the list, it is to be preserved, and except that is to be replaced with empty string from the text. Next, I used to ensure that sentence ends with proper punctuation marks. For this, I used conditional statement and mentioned that if the last text is not from in, like dot, exclamation sign and question mark, I used to append it with dot. Next, finally, I used to return the text. Now quickly move on to the next step, that is post preprocessing function. This function ensures that the first letter is always capitalized after summarization and also remove extra spaces from the generated summary. For this, I used to define a function called post process underscore summary, which consists one parameter, that is summary. Now summary.step remove the leading and trailing white space from the summary and store it to summary variable. Next, with the usage of conditional statement, if summary statement will check if the summary is not empty, then I used to define a variable called summary and mention that summary with index 0 access the first character of the summary. With the usage of upper function, it will be converted into uppercase later. Next, I used to add rest of the word to the summary and finally return summary variable. Now quickly move on to the main summarization function. This function combined pre-processing, summarization, post-processing into a single function. Ensure that summary is well formatted and ready to be used. So for this, I used to define a function called summarize underscore text with single parameter, that is text. Then I used to call pre-process underscore text function, and then inside that I used to pass text parameter and store it to the text variable. Next, with the usage of conditional statement, I also mentioned that if character length less than 50, it will shows warning message. Then I call summarizer pipeline, and inside that I used to pass text and defined maximum length and minimum length. And for deterministic output, I used to make sure that do underscore sample should be false. Now with return statement, I used to call post process underscore summary function, summary with index 0 with summary underscore text. This will extract the actual summary of the text from the output of the summarizer. Now finally come to the last step, where I used to create user interface using Gradio. So here as you can see, I used to define a variable called iFace, and with the usage of Gradio, I used to call interface class. Inside that I used to call a function called summarize underscore text and store it to the fn variable. Now for taking input, I used to define input as variable. With the usage of Gradio, I used to create a text box using gr.textbox function. I used to define line, placeholder and label. Now for taking output, I used to define output as variable. And with the usage of gr.textbox, I used to create a text box with label. Finally, I mentioned the title of the project with description and theme. Also mention live equal to false. For creating clear and submit button, now quickly I used to run the code and scroll it down. With the usage of iFace.launch function, I used to deploy the code on Gradio. As soon as I run the code, I will get the public URL. After clicking on it, wait for few seconds and you will redirect to the public user interface. So here as you can see, AI text summarizer consists two text boxes with two buttons, clear and submit. Now quickly I used to paste the text inside the text box and I scroll it down and click on submit option. As soon as I click on submit, I will get the summarized text inside the AI generated summary box. So this is how you can build AI powered text summarizer. I hope this video is informative. Please do like, share and subscribe for more informative videos. Hello guys, welcome back to the new videos of CodingPie. Today I am going to show you that how you can build machine learning web application that predict IPL score. This is project 6 out of 50 plus AI project. In this video, I will show you that how you can apply random forest regressor as a machine learning algorithm on top of dataset. So before we start, please hit like and subscribe button. So at first, upload the data on Google Colab just like so, and scroll it down and move on to the next step. And here as you can see, install all the dependencies which is required for this project. which include pandas, scikit-learn and gradu. In my case it is already installed, so it says requirement already satisfied, and some of the file still get downloading, so wait for a few seconds. And here as you can see, file get downloaded successfully. Now quickly move on to the next step, which is importing the important libraries. So here I used to install pandas as PD for data ingestion as well as manipulation, numpy as NP for mathematical computation, gradu as GR for creating user interface. From sklearn.model_selection, I used to import train_test_split in order to split our data into test dataset and train dataset. From sklearn.ensemble, I used to import random forest regressor as a machine learning algorithm. This is very powerful machine learning algorithm used for regression tasks. Finally, in order to evaluate our model, from sklearn.matrix, I used to import mean squared error and R2 score. Quickly run the code and move on to the next step, which is load and pre-process the data. And here as you can see, with the usage of pd.read_csv, I used to read the IPL dataset and store it to the data variable. Next I used to define the feature and target variable. For this I used to separate out all the important feature and store it to the feature variable. Next I define target variable, which is total. It indicates total IPL score. Now in order to pre-process the data, I used to remove the missing values from the dataset. For this, inside data.dropNA method, I used to pass feature as well as target variable, and I used to store it to the data variable. Next, I used to split the dataset into training dataset and testing dataset, which is correspond to the 80/20%. This is very important in any of the machine learning project in order to protect data from leakage. Training dataset is used to train our model, and testing dataset is used for model evaluation purpose. Quickly pass the feature dataset and target dataset to the train_test_split function with test_size would be 20%. Now store it to the 4 different variable, which is x_train, x_test, y_train, y_test. And at last, as you can see, x_train dot shape with index 0 give the training samples, and x_test dot shape with index 0 give the testing samples. Now quickly move on to the next step. Here in this step I used to apply random forest regressor as a machine learning algorithm on top of training dataset. And if we talk about random forest regressor, what really it is? Random forest is a flexible machine learning algorithm used for both regression as well as classification tasks. It uses ensemble approach, which can build multiple number of decision tree and averages their prediction. And here as you can see, inside the random forest regressor class, used to define n_estimator, which is 100. This is nothing but a number of decision tree with maximum depth equal to 20 and minimum sample split equal to 3. I also mentioned that random_state, which is equal to 42, it might be any value. And finally I used to fit the model on top of trained dataset. Quickly run the code, and as I see, model fitted perfectly on top of dataset. Now quickly move on to the next step. I need to evaluate the model performance. Now I used to pass x_test data to the rf_model.predict function and store it y_pred variable. Next I used to calculate the performance of the matrix. For this I used to define a variable called MSE. I call mean squared error function, and inside that I used to pass y_test and y_pred. Similarly for R2 score, used to define a variable called R2, where I call R2 score function. Inside that I also pass y_test, y_pred variable. Finally taking print of these two variables, MSE and R2. Now quickly I used to run the code. Finally I got the result. MSE equal to 356 and R2 score is equal to 0.57. Clearly says that model is underfitted. Requires hyperparameter tuning. In my upcoming videos I will show you that how you can apply hyperparameter tuning on top of dataset. But as of now it is good, so I used to go with it. Quickly move on to the next step. Finally, as you can see here, that I used to define a function for taking input from the gradu. For this I used to define a function called predict_total. I pass 5 parameters, which include over, run, wickets, run in last 5 hours, wicket in last 5 hours. Now with the usage of numpy, I used to convert this input into a numpy array. Then I used to store it in input_data variable. Next, inside the rf underscore model dot predict function, I used to pass input underscore data with index 0 and store it to the prediction variable. And at last, in return statement, I used to take print of these prediction variable. Now quickly move on to the last step. For creating stylish and attractive Gradio user interface, I used to define a variable called iFace. With the usage of Gradio, I used to call interface class. Inside that, I used to define a variable called fn. Here I call predict underscore total function. I used to define a variable called input. Based on input, I used to create a slider. Now at last, I also define a variable called output, which store output text. As usual, I used to define title and description and make sure that live is equal to false. With the usage of iFace.launch function, I used to deploy code on Gradio. So as soon as I run the code, I will get the public URL. When I used to click on it, I will redirect to the public UI. Here you can see the public user interface. Quickly scroll it down and click on submit button. As soon as you click on the submit button, you will get the predicted result. This is how you can build machine learning web application that predict IPL score. I hope this video is informative. Please don't forget to like, share and subscribe. Stay tuned for more update, and guys, trust me, slowly and gradually we gonna move on to the major projects. Hello guys, welcome back to the new videos of CodingPie. In this video I am going to show you that how you can build machine learning web application that predict price of the house. And in this video I will also show you that how you can apply multiple machine learning algorithm on top of data set. So without wasting time, let's get started. So first thing first, what you need to do, just install all the required library which is necessary for this project, which is pandas, numpy, scikit-learn and Gradio. And as you can see, in my case it is already installed, so it says requirement already satisfied. Now quickly come to the next step where I import all the required libraries. Now here as you can see, I used to import numpy as np for mathematical computation, pandas as pd for data ingestion as well as manipulation, Gradio as gr for creating stylish and attractive user interface. Now from sklearn.dataset I used to import California housing dataset. From sklearn.model_selection I used to import train_test_split, which is useful function to prevent data from leakage. Next I used to import all the necessary machine learning algorithm which is to be performed on top of dataset, which includes random forest regressor, linear regression, support vector regressor. Also from sklearn.preprocessing I used to import standard scaler. And if we talk about standard scaler, is a tool used in machine learning to adjust our data so that each feature column has an average of 0 and standard deviation of 1. Now at last from sklearn.matrix I used to import R2 score. So R2 score is a matrix used to evaluate our model. How will a regression model fits the data? Now after running the code, quickly move on to the next step, which is load and prepare the data. Now here as you can see, I used to call fetch_California_housing class. With the usage of this class, I used to load the California housing dataset and store it to the California variable. Next I used to filter out target variable as well as feature variable from the dataset. So California.data gives feature columns and which is to be stored in X variable. Then California.target gives the target column and which is to be stored in Y variable. Next I need to split dataset into training dataset and testing dataset. Training dataset is used to train our model, while testing dataset is used for validation purpose. So for this I used to call a function called train_test_split, where I used to pass my feature variable as well as target variable. I will also make sure that test size should be 20% and random_state would be 42, and in your case it might be any number, and quickly store it to their corresponding variable x_train, x_test, y_train, y_test. At last I used to do feature scaling on top of dataset. For this I used to call a standard scaler class and store it to the scalar variable. Next in scalar.fit_transform I used to pass x_train variable. and this is going to be stored in x underscore train underscore scaled variable. Now in scalar.transform I used to pass x underscore test, which is to be stored in x underscore test underscore scaled variable. Here one thing you will notice that I used scalar.fit underscore transform on top of train data and scalar.transform on top of test data. Why? Because the previous one is going to be used to train our model, and model requires consistent data for learning. So fit underscore transform computes the mean and standard deviation from training data set and scale it accordingly. Now quickly move on to the next step, where I used to apply multiple machine learning algorithm on top of dataset. So here as you can see, I used to define a variables called models, and inside the dictionary I used to call all the machine learning algorithms, which include linear regression. And if we talk about it, it is a simple machine learning algorithm used for predicting continuous target variable. Basically, it will find best fitting straight line that minimize the difference between the actual value and predicted value. Next is random forest regressor, which is an advanced machine learning algorithm that uses multiple decision tree to predict the continuous target variable. In my previous video, I explained this in detail. Link is in description. Please go and check it out for more information. Next, I used to call support vector regressor class. It is a powerful machine learning algorithm that uses support vector machine for regression task. Instead of finding best fit straight line, just like in linear regression, we are trying to fit a model within a margin of tolerance and minimizing the error. Next, I used to train and evaluate the models. For this, I used to define some variables like model scores, best models, and best scores. And also there is a for loop that iterates over the models, where name is model name and model is model object. Next, I used to train the model on scaled training data with the usage of model.fit function, where I used to pass x underscore train underscore scaled as feature variable and y underscore train as target variable. Next, in order to make prediction, I used to call model.predict function, where I used to pass x underscore test underscore scale data, and this is to be stored in y underscore pred variable. After that, I used to evaluate the performance of the model with the usage of R2 score. So for that, I call R2 score function, where I pass y underscore test and y underscore pred variable, and value is going to be stored in R2 variable. Next, with model score with index name, I need to round off the R2 score up to 4 decimal place. So in round function I pass R2, 4. Now finally, I used to filter out best model based on R2 score. For that, I use if conditional statement. I mention that R2 is greater than best score, then best score is R2 and best model is model. Quickly, I used to print model with their R2 score and also best model with their R2 score. So here as you can see, regression with 57% of accuracy, random forest with 80% of accuracy, and support vector machine with 72% of accuracy. So the best model is random forest regressor with 80% of accuracy. So I will continue with random forest regressor in next step. So in this step, I used to define a function that predicts the house of the price based on features. And here as you can see, predict underscore house underscore price is a function name with single parameter called features. Next, I used to convert feature into an array with the usage of numpy and reshape it into 2 dimensions and store it to the features variable. Then feature is going to be scaled with the usage of scalar.transform function, and then it is going to be stored under feature underscore scale variable. Next, I used to call best underscore model.predict function, where I pass feature underscore scaled variable and then store it to the prediction variable. Now finally, I will take the predicted price of house in return statement. Quickly move on to the next step, where I create user interface using Gradio. Here as you can see the entire code of dashboard, where I mentioned California house price prediction as markdown, and below that I also mentioned that best model selected, where I pass in dictionary best underscore model dot 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 this line of code, extract the best model. Now finally I used to define input with default values. So for that I used to define a variable called input, and inside the list with the usage of gr.number function you can mention label as well as default values just like so. Now quickly move on to the next step. Here with the usage of gr.textbox, create a text box with label equal to predicted price and value is equal to waiting for input. And this will be stored in output variable. Next, with the usage of gr.button, I used to create a button with predict name, and inside the click function I used to pass predict underscore house underscore price function, input variables and output variables. And finally with the usage of demo.launch function I used to deploy the code on GradeU. As soon as I run the code I will get the public URL. After clicking on it I will redirect to the public user interface. And here finally as you can see the complete user interface which named as California House Price Prediction, and I also mentioned the random forest regressor as best model selected. Below that there is a lot of feature column with their default input values, and if we're gonna click on predict option I will quickly get the predicted result. So this is how you can build a machine learning web application that predict the price of the house. I hope this video is informative. Please do like, share and subscribe for more upcoming projects. Hello guys, welcome back to the new videos of CodingPy. In this video I am gonna show you that how you can build digit recognition system using neural network. In this project you will learn about how to implement deep neural network on top of MNIST dataset. So without wasting time, let's get started. So first thing first, what you need to do, just install all the required libraries which include TensorFlow, GradeU, Matplotlib, NumPy and Pillow. In my case it is already installed, so it says requirement already satisfied. Now here as you can see I successfully installed all the required files. Now quickly move on to the next step where I used to import all the libraries. Now here as you can see I used to import TensorFlow and Keras for building and training the deep learning model. So from tensorflow.keras.layers I used to import convolutional, max pooling, flatten, dense and dropout layers. And if we're gonna talk about it, what convolutional layer really is, it's a filter that slide over image and detect pattern, which include age, texture or shape. Next is max pooling layer. The main purpose of this layer is to reduce the size of an image, and this is helpful to reduce the computation time. Next one is flatten layer. This layer convert the two-dimensional grid of number into a one-dimensional list of number and prepare the data for final decision making. Next is dense layer. I already talked about it in very detail in my previous video. As of now it is fully connected layer, which means every neurons from the one layer is connected to the every neurons to the next layer that combine the pattern and make prediction. Now next one is dropout layer. This layer randomly turn off some neurons and prevent model from overfitting. Next I used to import NumPy as NP for numerical operation. Next is matplotlib.pyplot as PLT to visualize our dataset. Next I used to import GradeU as GR for creating user interface. At last I used to import imageOps from PIL for image handling. Now quickly move on to the next step where I used to load and pre-process the MNIST dataset. And here as you can see I used to import data from Keras. So for that I used to call load_data function with the usage of keras.dataset.mnist and then store it to their corresponding variable, which is x_train, y_train, x_test, y_test. And here x_train and x_test represent grayscale images with 28 by 28 pixels. Similarly, y_train and y_test represents labels, which is 0 to 9 digit. Next I used to reshape the dataset for CNN input. In order to do so I used to call reshape function, and inside that I used to pass -1, 28, 28, 1. where -1 represent the total number of dataset, which is 60,000. Then 28,28 represent pixels, and here 1 represent the single color, which is grayscale. After this, I used to convert it into a float with the usage of as type function. Then I used to normalize it by dividing by 255. Finally, I used to store it to the x_trend variable. And similarly, I used to do same for test data, and then I used to store it to the x_test variable. Next, I used to convert the label into one hot encoded vector, because the model output layer predict the probabilities for each 10 classes. So in order to do so, from keras.utils, I used to call to_categorical function, where I used to pass y_train with 10 labels. Then I used to store it to their corresponding variable, that is y_train, and as well as I used to do same with y_test data. Now quickly I used to run the code and move on to the next step, which is visualize the sampled images. And here, as you can see, first I define a variable called figure and axis, whereas axis represent a list of 10 subplot. And I used to call plt.subplot function that will create a blank canvas with 1 row and 10 column. And I also pass figure size with 10 unit wide and 2 unit tall. Then with the usage of for loop, I used to iterate image up to 10 times. And with the usage of axis with index I used to call IAmShow function, where I used to pass x_trend with index I dot reshape, where I pass 28 by 28 pixel with cmap equal to gray. Next, axis with index I dot axis I used to pass off. This line of code is used to hide the axis label. And with the usage of plot function, I used to show the final plot. I include this step intentionally for two purposes. First, to visualize the dataset. Second, you have to notice one thing over here. My model is going to be trained on image with black background with white pin color, so it requires inversion before feeding it. Now quickly move on to the next step, where I used to build the CNN model. So first thing first, I used to define a variable called model. Then from keras, I used to import sequential approach. I used to pass all kind of neural layer. And if we talk about first layer, that is convolutional neural layer, this layer basically extract feature from the images. Here I define 32 filter with 3 by 3 pixels. For input_shape equal to 28 by 28 pixels with one color channel. I also mentioned that activation function is ReLU. And if we're gonna talk about it, ReLU as activation function knows that when to fire neuron or when not to fire neuron. This thing I already explained it in detail in my previous video. Next is max pooling layer. This layer reduces the size of the image while keeping the important features. And here I used to pass 2 by 2 maximum value for every grid. That will reduce the image size by half. That is 14 by 14 with one color. Now in next convolutional neural layer, I used to increase the number of filter with same kernel and same activation function. Don't worry about the word kernel, because 3 by 3 pixels together called as kernel. Next, again with the usage of max pooling layer, I used to downsampling the images while maintaining its important features. This layer further reduced the size of image from 14 by 14 to 7 by 7. Next is flatten layer, where I used to convert two-dimensional grid of number into one-dimensional list. So if you're gonna multiply it 7 by 7 by 64, you will get 3136 number. So this number is required before feeding data into the dense layer. And next is dense layer, which is fully connected layer, where I used to pass 128 neurons with activation function ReLU, and this layer combined all the detected patterns and act as a brain that interpret features for classification. The next one is dropout layer. And here, as you can see, I used to pass 0.5, which indicate 50% of neuron. This is quite important layer, because this is randomly turn off 50% of neuron during training and prevent model from overfitting. Now in last dense layer, which is also called as output layer, here I used to pass 10 neurons, which is correspond to the 10 output features. And here I use softmax as activation function for multi-class classification that convert output into probabilities and make final prediction. Now quickly I used to run the code and move on to the next step. This is step 5, where I used to compile and train the model. Now with the usage of model.compile function, where I used to pass Adam as optimizer, which is an algorithm that adjusts the model weight and minimize the error during training. Next, I use categorical underscore cross entropy as loss function that measures how wrong the model's prediction as compared to the true label, and this loss function works best for any classification problem. Next, I also define the type of matrix, that is accuracy, which track the percentage of correct prediction during training. After compilation, I used to train the model, so for that I used to call model.fit function, where I used to pass x underscore train data, y underscore train data with epoch size 5 and batch size 128, and along with this I also pass validation data set, which include x underscore test, y underscore test. Now quickly I run the code and move on to the next step. This will take a lot of time, so I used to skip some of its part, and here as you can see I successfully run the code with 98% of model accuracy. Now next I used to save the model with the usage of model.save function, where I used to pass model name, that is MNIST.h5. Quickly move on to the last step, where I used to create user interface using Gradio. And here as you can see, first I used to import model with the usage of tf.keras.models.load_models function, where I used to pass model name, that is MNIST.h5, and store it to the models variable. Next I used to define a function called predict_digit with one parameter, that is image. First I used to handle the image which do not contain any number with the usage of conditional statement. Here I mentioned that if image is none, then in return it gives a message that no image detected. Next I used to convert image into grayscale. So image class provide a function called fromArray, where I pass image, and with the usage of convert function, where I pass L, then store it to their image variable. Together this line of code ensure that image is black and white. Next I used to invert the color of input images, which contain white background and black pin color. Now in order to do so, I used to call imageOps class, which provide invert function, where I pass image variable and then store it to the image variable. Next I used to resize the image up to 28 by 28 pixels, and this is gonna be done with the usage of image.resize function, where I pass 28,28 and store it to the image variable. Because our model is trained on 28 by 28 pixels images, so it is necessary. Now finally I used to convert an image into an array with the usage of numpy and store it to the image variable again. Then after I used to normalize the number by dividing 255 after converting it into a float number. Then I used to store it to the image variable. Now finally, in order to predict the digit, first I used to define a variable called prediction. Then I call model.predict function, where I pass image variable. Next with the usage of np.argmax function, where I pass prediction variable. So argmax function picks the digit with their highest probability and store it to the digit variable. Now at last, in return statement, I used to print out the predicted digit. Now finally I come to the last step, where I used to create user interface with the usage of Gradio. This is quite easy and simple step. So quickly I used to run the code. As soon as I run the code, I will get the public URL. After clicking on it, I will redirect to the public user interface. And here as you can see, there is a title, that is upload a number below, with two boxes and one predict button. The first one is used to upload an image and the another one is used for prediction purpose. Then quickly I used to upload an image, and as soon as I click on predict button, I will got the result in prediction box. So this is how you can build handwritten digit recognition system using neural network. I hope this video is informative. Please do like, share and subscribe for more upcoming projects. Hello guys, welcome back to the new videos of Coding By. In this video I am going to show you that how you can build customer support chatbot. This is project 9 out of 50 plus AI projects. Through all this project you will not only enhance your knowledge but also boost up your coding skill. So without wasting more time, let's get started. So before we start, if you are new to my YouTube channel, then please hit like and subscribe button. So quickly installed all the required libraries which is necessary for this project. Here as you can see I used to install Gradio, NLTK and scikit-learn libraries. In my case it is already installed, so it says requirement already satisfied. Now quickly I move on to the next step. Here I import all the necessary libraries which is required to build this project. And here as you can see I used to import Gradio as GR. It is a Python library used for creating user-friendly web interface for machine learning model. It allows user to interact with model through input field, button and slider. Next is NLTK, which stands for Natural Language Toolkit, which is a powerful Python library for working with human language data or text. It provides various tools for tasks like tokenization, stemming and lemmatization and so on. Now from sklearn.feature_extraction.txt, I used to import TF-IDF vectorizer. Here TF-IDF stands for Term Frequency Inverse Document Frequency, which is a method that is used to convert text data into numerical feature vector. Basically, it measures how important a word to a document in a collection of documents. Now from sklearn.matrix.pairwise, I used to import cosine_similarity. So if we talk about cosine similarity, which is a function that is used to compute cosine similarities between two vectors, which means that how two pieces of text are similar to each other based on their vector representation. Next I used to import NumPy as NP, which is a fundamental library in Python used for numerical computation. It provides support for an array, matrix and mathematical operations. Next I used to download punct dataset from NLTK, which contain pre-trained model for tokenization. And if we talk about tokenization, what really it is a process which are used to split a sentence into list of words. Now quickly I used to run this line of code, and as you can see I successfully downloaded the punct. Now quickly I move on to the next step. And here as you can see I used to define FAQs and general chat response content. Both of these two things stored in the form of dictionary. And if we talk about what dictionary in Python, it stores data in the form of key value pair under the curly braces, where keys are immutable and values are mutable. Here this content I used to store to their corresponding variable, which is FAQ and general_chat. Quickly I used to combine these two things together. So for that, first I used to define a variable called FAQ_questions. Then with the usage of FAQs.keys function, used to extract all the keys from FAQs dictionary. Then I used to convert it into a list of questions with the usage of list function and store it to FAQ_question variable. After that I used to define another variable, that is FAQ_response. Then with the usage of FAQ.values function, I used to extract all the answers from the FAQs dictionary, and after converting it into a list of answers, I used to store it to the FAQ_response variable. Next, same I used to do with general_chat dictionary. Similarly, first I used to define a variable called general_questions and general_responses. Then extracting questions and answers from general_chat with the usage of keys and values function. After converting it into a list of question and answer, I used to store it to their corresponding variable. Next I used to combine all the questions together and all the answers together. So for that I used to define a variable called all_questions. Here I pass FAQ_question plus general_question. Similarly for all_responses variable, FAQ_responses plus general_responses. Now next I used to convert questions into numerical vector with the usage of TF-IDF. So for that I used to call a class TF-IDF vectorizer and store it to a vectorizer variable. This line of code initializes an instance of TF-IDF vectorizer class from sklearn.feature_extraction.txt module. As I said earlier, it is used to convert text data into numerical feature vector, which is necessary for performing text similarity calculation. So with the usage of vectorizer.fit_transform, where I pass all_question, I convert all the questions into numerical feature vector and then store it FAQ_vector variable. And this vector is going to be used further for cosine similarities, which is a mathematical computation. Now quickly I used to move on to the next step, where I used to define a function for response matching. Here as you can see, with the usage of def keyword, I used to define a function called chatbot underscore response, where I pass user underscore input variable, and here as you can see user underscore input dot lower function dot strip function. So first, with the usage of lower function, it will convert input text into lowercase and ensure case insensitivity. Then with the usage of strip function, I used to remove leading as well as trailing white space from the input text. This is simple pre-processing step which is required before feeding it to the vectorizer class. Next, with the usage of vectorizer.transform, where I pass list of user input. This line of code convert the user input text into numerical vector. The usage of term frequency inverse document frequency vectorizer, which I used to define earlier as vectorizer. Then store it to the user underscore vector variable. Next, I used to call cosine underscore similarity function, where I used to pass user underscore vector, comma, FAQ underscore vectors. This will compute the cosine similarity between the user's input vector and FAQ underscore vectors. And this will return a matrix of similarity scores, which need to be converted into one-dimensional array with the usage of flatten function. Then whatever value that come after it, I used to store it to the similarities variable. I used to find the best match, so for that, the usage of np.rmax function, where I pass similarities variable, extract the index of highest similarity score from the similarities array. This index corresponds to the quotients in all quotients variable that is most similar to the user input. Then I used to store it to the best underscore match underscore idx variable. Now next, I used to check the confidence level. So for that, with the usage of if conditional statement, I used to perform checks on similarities with index best underscore match underscore idx. If it is greater than 0.3 confidence level, I used to return response from all underscore response with index best underscore match underscore idx. Otherwise, in return statement, I leave a message that I am sorry, I don't have an answer for that. Please contact support. Now quickly move on to the next step, where I used to create user interface using Gradio. So here as you can see, first I used to define a variable called interface. Then with the usage of alias gr, I used to call interface class. Here I define fn as variable, where I pass chatbot underscore response function. Next, I used to define a variable called input. Then I create a text box with the usage of gr.textbox function. And inside that function, I used to define placeholder and label. Next, I used to define a variable called output. And again, I need to create a text box with the usage of gr.textbox function, where I pass label. Then I used to define title, description and theme. Now finally, with the usage of interface.launch function, I used to deploy the code on Gradio. So as soon as I run the code, I will get the public URL, and as you can see, after clicking on it, I will redirect to the public user interface. Here as you can see, Customer Support Chatbot with 2 text box and 2 button, that is clear and submit. So whenever you write anything inside the chat with Customer Support Bot, it will reflect the response in Chatbot response text box. So this is how you can build Customer Support Chatbot AI. I hope this video is informative. Please do like, share and subscribe for more upcoming projects. Hello guys, welcome back to the new project of CodingPie. This is project 10 out of 50 plus AI project. In this project, I will show you that how you can apply YOLO V5 object detection on top of recorded videos. So if you were new to our YouTube channel, then please hit like and subscribe button before you miss any update. And without wasting more time, let's get started. So here as you can see, I used to install all the required libraries which is necessary for this project, which include Gradio, Torch, Torch Vision, Torch Audio, OpenCV Python, Ultralytics and FFmpeg Python. And in my case it is already installed, so it says requirement already satisfied. Now quickly I used to move on to the next step, where I import all the required libraries which is necessary for this project, which includes Gradio as GR for creating user interface, Torch is used for loading the YOLO V5 model, and CV2 is basically used for video processing, and if we're gonna talk about OS, it is basically used for file handling. Quickly I used to move on to the next step where we can load the pre-trained model, that is YOLO v5. So first I used to define a variable called model. Then with the usage of torch.hub.load function where I used to pass alternatic/YOLO v5, YOLO v5s. Here torch.hub is a PyTorch utilities that allows users to load model, dataset and other resources directly from GitHub repositories. So inside the load function, alternatic/YOLO v5 is a repository path where YOLO v5 model is hosted, and YOLO v5s is the smallest variant of YOLO v5 model. And if we're gonna talk about it, it is a lightweight pre-trained model that is used for object detection and commonly used for lightweight application. Now quickly I used to move on to the next step where I used to define object detection function. Here as you can see, with the usage of def keyword, I used to define a function called object detection on video where I pass video_path as parameter. This function encapsulates the logic for performing object detection on top of videos. Next, with the usage of CV2 where I call a class video capture where I pass video_path. This line of code open the video file specified by video_path, then store it to the cap variable. This cap object is used to read frame from the videos. Next, with the usage of conditional statement, I used to check if video is opened or not, and if it is not, then it returns a message that is error could not open video. This line of code ensures that the program handles cases like video file is missing or corrupted. This will play a very crucial role to prevent runtime error. Next, I want the video properties like frame width, frame height and FPS. And with the usage of cap.get function, I pass cv2.cap_prop_frame_width. I used to convert it into a numerical format with the usage of int and store it to the frame_width. Same I used to perform on top of frame_height and FPS. These properties are quite important in order to configure the output video file, so it matches the input video resolution and frame rate. So for output file, first I used to define a variable called output_file and specify their name output.mp4. Then with the usage of cv2 video writer class, output_file cv2.videowriter_4cc where I pass mp4, fps, and inside the round bracket I used to pass frame width and frame height. Now quickly I used to store it to the out variable. Next I used to count the total number of persons. So for that I used to define a variable called total_people_count variable and store 0 to it. This variable accumulates the count of peoples across all frames. Next, with the usage of while loop, I used to process video frame by frame. So inside the while loop I used to call cap.read function. This function is used to read the next frame from the video. Then I used to restore it to their corresponding variable, that is read and frame. Read basically store a boolean indicating whether a frame successfully read or not, and frame contain the image data of current frame. Then with the usage of conditional statement I used to break the loop if the frame is not successfully read. And finally, in order to detect object, I used to pass frame inside the model object and store it to the result variable. Next I used to extract detected class. So for this, result.xywh with index 0 which contain the bounding boxes and class IDs of detected objects, and again adding index with -1, used to select the last column which contain the class IDs. Then with the usage of cpu.numpy, I used to convert tensor into numpy array for fast processing, then store it to the detected_class variable. This line of code acts as a filter which counts a specific object in a frame. Next I used to count the number of peoples in the current frame and then add it to the total count. Then with the usage of condition detected_classes == 0, perform checks on frame that detected objects are peoples. And with the usage of sum function I used to count the number of true values and store it to the people_in_frame variable. Then I used to add it to the total_people_count variable. So this line of code keeps track total number of peoples detected across all frames. Next I used to render detection on top of frame. So for that, the usage of results.render function with index 0 over relay the detected object on the current frames. Then store it to the frame variable. This line of code visualize the detection result and make it easier to understand what model actually detected. Next, with the usage of out.write function where I used to pass frame, this line of code write the processed frame to the output video file. So this will generate output video with detected result. And finally I used to release the video with the usage of cap.release function, and same I used to perform on top of output video. This line of code ensured that proper cleanup after processing the video. Next I used to convert a video to a web friendly format using ffmpeg. Here as you can see, with the usage of os.system, I used to pass ffmpeg on top of output_video file. Finally in return statement I used to print total people detected. So I passed total_people_count inside the curly braces. Quickly I used to move on to the final step where I used to create user interface using Gradio. And here as you can see, first I used to define a variable called iFace, and with the usage of gr I used to call interface class. Inside that class I used to define a variable called fn. I used to call a function object detection on video. Next I used to define input as variable. With the usage of gr.video I used to take video as input. Next I used to define output as variable, and I used to create a text box with the usage of gr.textbox. Here I release processed video with the usage of gr.video. Next I used to define title and description of this project. Finally with the usage of iFace.launch function I used to deploy code on Gradio, and as soon as I run the code I will get the public URL. After clicking on it I will redirect to the public user interface. And here as you can see the entire user interface of this project. Now quickly I used to upload a recorded video. After that I used to click on submit button. As soon as I click on submit I will get the predicted result. And here as you can see the total number of detected peoples. Also you may notice in output video YOLO V5 not only detect person but also detect what they are carrying. Hope this video is informative. Please do like, share and subscribe for more upcoming projects.